Welcome to this webinar on serious games in the water industry, featuring Dr Mehdi Khoury of the University of Exeter and Oliver Grievson, our host for the day, from Wastewater Education 501 and Water Industry Process Automation and Control. Please enjoy this webinar and do catch our other webinars available on YouTube.
So, good afternoon, good morning, good evening, wherever you are in the world. Welcome to this Wastewater Education 501 webinar workshop on serious gaming in the water industry. My name is Oliver Grievson. I'm the Chairman of Wastewater Education 501, and I'm joined by Dr Mehdi Khoury of the University of Exeter, who is a serious games expert. Mehdi, welcome.
Hello, Oliver, and hello, everybody. It's nice to be able to talk about my favorite subject.
Serious games. Give me a little bit of background, Mehdi.
All right. So serious games are defined usually as games made for a purpose other than just entertainment. So these are games which are designed so that you learn stuff when you use them. So they can be used for training. They can be used for learning. And in fact, recently, it's been proved that if you've got an 80-page long report to go through to learn something about the content of, let's say, some flood output or some complex system, if you have a game in which you practice the different mechanism of that content, you will retain a lot more by playing the game and practicing than you will by just reading the 80-page long report. So even better than that, with the new serious games, they're online, so they are multi-players or multi-users. So you can actually combine teams of people and they can learn to work together in some sort of big process so as to optimize different goals, even if their individual goals sometimes might be, opposite or not going in the same direction.
I know when we've spoken in the past, and we've spoken quite extensively about serious games, I've always thought that the big market, and especially for water companies, I mean, we're here in the UK, but it equally applies to the US, where wastewater education is based, or anywhere where you're dealing with the water system. I've always thought actually delivering complex concepts to customers is a big market, is a big area where the water companies can collaborate, I dare to say, I don't really want to say educate, but yes, educate the customers about what's going on. And I know you've got a case study of a serious game you developed in Millbrook,
yes,
where this was the case.
So yes, you're touching another part of it, which is probably the most interesting part for the industry. There is a crisis. There is an environmental crisis. Water supply are not unlimited, and the regulator is starting to, show a little bit of tough love for water companies because they don't necessarily always engage with the public. But the public is not aware at all that water is not infinite, right? I mean, the water tap just open, it's magical, the water comes out. No, that's true for most people. That's exactly what's happening. So serious games are a really nice way to engage with these people, with the customers, with the stakeholders, and to show them how this system is on a fine edge and what kind of things can be done to do damage control, particularly in the present news, for example, about CSO events where you've got discharges in rivers of untreated water, and people are being totally scandalized by it without actually knowing the full picture. It's a lot more complicated than what it seems. And everybody's got a part to play in it. So it's important as a medium to show people that have a part to play in things, how they can play this part to make the whole picture better. So I'm going to show you, if you want, I'm going to demonstrate Millbrook as a proof of concept. And then I'll show you the latest baby, which was in the latest thing which was fresh from the oven, which is the next gen game.
So yeah, let's have a look at Millbrook. Let's show people the concept of what a serious game can do. I know there's a bit of a bit of a back history to Millbrook. So if you bring up the game, but almost tell us the back history of why Millbrook was developed.
Yeah,
that'd be
absolutely.
great.
If you allow me to share my screen, because I've got this magical message: host disabled participant screen sharing.
There we go. You should be able to do that right now.
Oh, magical. Let's give it a go.
Perfect.
So, can you see my screen?
I certainly can. I love your background desktop.
Yes, I am not the one climbing this cliff. Just in case if you see the small guy here, that's not me. It's just a pure accident of the Windows desktop. So I'm going to start Millbrook, and then I will tell you a little bit about what's happening there. So I'm going to probably mute the sound of this Millbrook thing, or I don't know if I can mute it, but anyway, what you're seeing behind is the village of Millbrook. And it's located near Plymouth in the United Kingdom. And what happened is, for the past few years, the residents have been flooded in the village of Millbrook, and they've been badly flooded. So there is here you've got this little serious game interface in which you can actually see your small model of Millbrook, on which we're going to inflict a lot of trouble. And there is also on this virtual table inside the game a little bit of history. And what you're seeing there is the flood print of the previous flooding event in Millbrook. So it's a tiny village, and the center of the village is flooded pretty badly. There's commercial shops, pharmacy, and all sorts of residence housing on the way. There's been some damage, not just once, but I think twice in the past 5 years, and substantial damage. So what happened is I was invited to come to a meeting between the Southwest River Trust and the residents of Millbrook, which received a report regarding why this flooding was happening. And it was a very tense situation. In British term, this was the equivalent of a riot, in the sense that people stayed polite, and shakably so, were drinking tea, but were very much politely pointing that it was the fault of the water company if they were flooded. The event itself, what happened is the water company provided, let me show you what happened in here. Provided a report, and what happens is, after let's say a couple of hours of rain, during this big rain that happened in the past, the Millbrook was flooded that way. And the way the residents thought, they thought that this little reservoir on the side connected to the sea, and isolated by a dike, but they thought that when it was raining, the reservoir was overflowing into the village, which is actually not. Yeah.
So just for people who are saying this, red is flooded. Amber is
when it's red. When a building is red, that means there's more than 50 centimeters of water inside the house. And when it's orange, there's between 30 centimeter and 50 centimeter of water inside.
So for our American cousins, almost 2 foot at red, and between 1 foot and 1.5 foot for an orange building. So
absolutely.
Almost up to your knee in some place and up to your waist in others.
Yeah, and it didn't happen once, it happened twice, and more than twice actually, but in the past 5 years it happened twice. You imagine the electrics being destroyed, the cars, all the work that goes with it. So we made a small estimation of the flood damage just regarding the buildings and for the village. And you could see, this is not good, right? The residents were understandably upset, and they thought, it's because of this reservoir, it probably overflows, and then the village is flooded. But the report that they were given by the water company was saying that no, it wasn't coming from the reservoir. It was actually coming from, the water all around the village. Now,
so really upsetting, to be honest, from a customer point of view. quite an upsetting situation of your house is flooded. Mm-hmm. You think it's the water company, and they're going, well, we've looked at it, and they're going, it's not us. And I can see in the top left corner, 2.4 million. Of course, that doesn't include the emotional damage to people in the village either. So
no, and the cars and the disturbance to their job, work, life, and all the insurance that doesn't really exist, the property value that just falls down drastically. I mean, all that. And this is a situation typically where you have a bunch of stakeholders which look at the situation and go, this is not possible. What are we going to do? Somebody must be surely to blame for that. And that's understandable. That would be the first reaction. What is happening is the fields all around Millbrook. Millbrook first is at the bottom. So if I actually rotate around, if you can you see?
Yeah, you can see the topography. It's kind of in a big funnel.
Yeah, it's just a big bowl, basically. It funnels the water. So that's the first problem. They are located in at the bottom of this bowl.
In the floodplain, basically.
Yeah. And another thing is, if you look at the detail of the terrain, what you observe here, look, can you see the cow's path traces and all that?
Yeah.
So it's intensive kind of animal. Yeah. And what's happening is the water, when it falls, instead of being absorbed by a bit of forest or nice grass or something like that, it just, there is this compacted earth. The water just flows straight down all at the same time and makes you makes this flood situation. So we needed to engage people, but more than that, to show them some sort of solution, some sort of possibility to minimize damage. Mm-hmm. So this is what's happening. We divided, if you can see there on the screen, the area between the catchment between three areas, region 1, 2, and 3. Because in fact, most of the land around the village is owned by 3 farms. So, and now we also allowed people to drag and drop different types of crops. So, for example, what's happening in Millbrook at the moment, you've got heavily grazed permanent pasture mixed with intensive arable with tillage. So it's a mix of both things, and that gives you this kind of flood print for this rain event, for this rainfall event. But there are always different ways to put your crops, and particularly at the bottom, there are ways to see what happens if you use no-till type of way of planting. So you don't till the earth, and instead you just plant a small amount of beans on the surface as well, and you see what happens. And of course, when you change your crop, it has an implication here on the water infiltration rate of the soil, but also on terrain roughness. I mean, if you've got lots of trees, that will break the speed of the water. If you've got also, depending on the type of culture, it might increase the amount of sediment that could lead to blockage in the drain pipes. And finally, we looked a little bit as a very rough measure of farming profitability, what could go up and down. The present situation, intensive cattle, intensive grazed permanent pasture is actually not super profitable. In fact, it was mostly subsidized by the European Union as far as the farmer were concerned.
I suppose that also fits in with people practices. I mean, we're seeing the big green recovery, and we're being told that actually we should eat less meat, and we are on Earth Day, so we can talk about this sort of thing. We should eat less meat, and as we do that, of course, probably the farming profitability will get less and less as demand goes down.
Well, it's disputable. Actually, it's the opposite that's happening there. If you ditch heavily grazed permanent pasture for no-till kind of culture with a mix of crops, that actually becomes more profitable. So,
what I'm saying there is if you had the heavily grazed cattle, I think moving forward, if people move towards more of a vegetable lifestyle, that the profitability of the heavily grazed will get even worse.
Yeah, definitely.
Yeah. So it's moving forward. I think we're probably, should we be going more towards the no-till? I'm not a farmer, so I'm sure I'll get shot down in flames for it. But yeah.
But to put that in context, we also entered in that game the possibility to have bigger pipes under the village, to have a bigger, sewer kind of an infrastructure investment with a bigger capacity for absorption for the water. Mm-hmm. So what's going on is we've got this low cost infrastructure, which is by default what the village is able to cope with. And if we add something a lot more expensive, which would double the capacity for handling this amount of water, if I click on this checkbox, we will see what happens to the flood print. Okay, if I click on high level infrastructure investment, it's going to take a second or a little bit more to. So look, I've clicked, nothing happens. I'm going to click back to the original one. Can you see any difference in the flood print?
No.
There is strictly no difference.
Double the price for very little impact, I suppose, because it's still going down the sewer, and yeah.
So that's the solution people wanted. They wanted, okay, let's have the water company build a bigger bunch of pipes under the village, and that will save us. But from this simulation result, it's not going to do much. But if you start dragging and dropping this no-tile type of crops in the 3 different areas around the catchment, look what will happen, okay? So I'm going to start dragging and dropping on this region, something. You should see a change on this region and on this region. Now, can you see? That's 95% of your flood, which is neutralized.
So you've still got some houses that are going to flood.
Yeah.
I presume closest to the river and closest to the low points and everything else. But yeah, you've massively reduced the houses at risk and massively reduced the impact on the customer.
So you've created that. You've created that impact. You've neutralized most of the flood, and in fact, the infrastructure cost is minimal, because what you are doing is you're helping the farmer to change their crops, and you've increased the actual farming profitability while doing so.
So again, I think you had about the damage was about 3 million. That's gone down to about 800,000. But which is offset by an increase in farming profitability by 73k.
Yeah.
So you're talking, okay, I don't know what sort of return event this was, but so how many floods were there in the period? There were 2, I think you were saying.
Yeah, 2 in the last 5 years.
2 in 5 years. So yeah, you're still going to lose money on that, but yeah, that's quite a big change. So how was this sort of, I know you did a lot of work developing this serious game. How was this almost conveyed to the public?
Okay, so we invited people, residents from the village. We just invited them to play the game. And unfortunately, not many people were able to attend. It was in a place lost in the middle of nowhere. Beautiful place, though. But we had 2 people coming. One was actually the accountant of the parish. There's a little bit of wisdom about inviting the accountant of the whatever organization or the parish to play your games, to see the merit of the solution. So what happened is we gave them a questionnaire about what they thought before playing the game, well, what they thought the solution to this problem was. And in the questionnaire, we said things like, for example, do you think that building bigger pipes under the village is a solution to that flooding problem? And most of them said, well, yeah, before playing the game. And after playing the game, we gave them the same questionnaire again. And then they changed their mind. They answered differently. So we could prove that playing the game induced statistically valid change for all the participants. Well, of course, we used more than just 2 participants. We had different sessions with other people than just the residents of Millbrook. But what happened was the accountant of the parish, having seen the difference in the expenses and in the results, actually pushed for this agenda in the parish, and now a natural-based solution became the priority. Nature-based solution, and things like helping the farmers and changing the crops are now on the agenda. And things have been turned around. So it's like a near perfect example of how a serious game can induce change and minimize somehow the friction and prevent that particular problem. So that's basically what happened with Millbrook. But now we're entering a new period, and I feel like it's getting interesting to show you the latest thing.
Well, let's pause and play around with the concept. I mean, obviously with Millbrook, the accountant came along, people came along. How do you counter them saying, well, this is a game? Does it really represent reality?
Well, this was a game, but this was a game with a simulation engine in the background with some very serious, hydrological study and some simulation engine where the results were computed via GPU computers and stored, so we could, evaluate all the possible scenario and the consequences. What's interesting about it is I contacted a soil scientist, which was able, by looking at the existing composition of the soil and also the way they were doing crops in Millbrook, he was able to derive for us the properties of the soil and how it could absorb water and how that could absorb water differently depending on the crops. So there was a very serious thing. Of course, you could try to sell something to people with a model that's totally bogus, but in our case, we had some serious research behind it. So the limit of the system, of course, is the amount of effort you put into it. And you must usually, as a serious game, you have a responsibility to make sure you show people something that's backed up by some science.
Yeah. But what does it take to put together a serious game? I'm a water company. I'm going to come to you. I'm going to come to you with a problem, and I'm going to come to you with Millbrook, and great. I can. Me as an engineer, I can see what's behind that. But I imagine right now, serious games. I've known you for about 2 or 3 years. Millbrook was before I knew you. How on earth I can see the use of it. We've talked about in the past. In the UK, we've got the price review and AMP cycle. And I've certainly talked to you in the past about one of the jobs the water companies do is work with the customers to understand where the investment is. I've always called the water industry the great hidden industry. As we said earlier, you open the tap, you flush the loo, you forget about the rest. I've always thought for the price review process, almost a mini serious game of running the water company. You invest 25 million, you invest 10% of the AMP in leakage, and something else happens. And I think with the water companies, they're always juggling at the minute. At the minute, pollutions are a massive issue. And I know pollution's a part of the serious game we're going to see in a few minutes. But there's always the next issue. There's always, I've been watching the Environmental Audit Committee in the UK. They've been having evidence from people around CSOs and pollution events. There's a job around, there's education around the public and wet wipes. Maybe that's, to me, one of the things we could do almost in the pollution thing is make people aware of the water and wastewater system. So yes, if you put wet wipes down, have that serious game, you're a customer, you have somebody putting wet wipes down at one end, and show them it's going to block the river, it's going to block the sewer, that's going to cause, in a storm, everything to come out the CSOs. And what impact does that blockage have on the river itself? I think there's so much that can be done with customer education.
It's beyond just the customers, because it's related to lots of domains like energy footprint, environmental flow, all these things. So what's happening is it's not just how the person consumes water, it's also when you build a house, should you add a little device on the side? Should you use rainwater harvesting? Should you even add some fancy dry flushing or vacuum toilet to it because you're environmentally, oriented? Or, what kind of solution work the best for the overall system? It's not super obvious at first. You might think that if you just throw money at the problem, it might solve it by just putting all the possible devices you can think of. But actually, no, some combinations work particularly well, and some other combinations are a bit of a waste of money. And so it's kind of a wise way to, like a manual. If you play through that, you could see if you're a builder, for example, or if you're a planner, the way you could potentially arrange things together. For example, killer combination, I'll talk about that later. But if you have somehow rainwater harvesting and you combine it with a sustainable urban drainage system, or sustainable drainage system, doesn't have to be urban, then suddenly this is a killer combination that absolutely reduce the amount of leakage of untreated water that would come in the river. And for much cheaper than having to rebuild the whole sewer infrastructure to be not combined, but to actually separate the rainwater from the sewers. So
it's almost it's not going to apply to everywhere, of course, but it's almost like a cheaper way of decombining our sewers in a way.
Yeah, and it's not just it's not just the fact that you could find from an environmental footprint, from a water footprint, from an energy footprint where you're going, but you can also combine it with other things. For example, what would happen if at the wastewater treatment plant you can recycle some of the traces of metals or exotic bits and pieces that you find in there? There is this concept that if you manage to grab and recycle 1 kilo of aluminium, for example, this kilo of aluminium, you won't have to go mine it and refine it from scratch. So that means that it's energy-wise, you gain something like, was it 200 miles on the Tesla Model 3 kind of energy-wise, just by... Yeah, that's what you would save in the overall system by not, having to mine from scratch all these traces that you can grab from the sewers. There is some untapped resources there as well.
It's very much the circular economy of the sort of approach of getting the value from the waste.
Yeah. So there is that. Perhaps I can demonstrate because.
Yeah, definitely.
We have been talking about it, but sometimes it helps to see the thing. So this is a little introduction. This is actually a browser-based game. It's a prototype, so it's not completely finished. But what you can see in front of you is what we call Toy Town. Toy Town could be in the UK, could be in the Mediterranean.
Doesn't matter where it is. Yeah.
Yeah. It's a generic setting. You got a main reservoir that lets some water go to the river. Here you got a drinking water treatment plant that takes water from the reservoir, and then this treated water goes to the neighborhoods in your town. And the different groups of house, at the moment, we just have one group A, 100% of the house, but we could do different partitions with different house with different technologies inside. Here, the water, the gray water, the black water comes out to the central water treatment plant at the bottom.
So very much a combined system.
Yeah.
Like so we have in the UK at the minute. Yeah.
Exactly. This is like a generic combined system. Here you've got a decentralized wastewater treatment plant. So we can decide for a portion of the houses in the neighborhood to connect them to a decentralized wastewater treatment plant and see the impact on the overall picture. And here we got a sustainable drainage system. We can also have a connection so that, for example, there is some of the gray water that comes out can be lightly treated and put directly in the sustainable drainage system, and that allows some sort of dampening, so that when you have heavy rains, suddenly all the rain doesn't come in one magic big wall to your water treatment plant, which is suddenly overcome.
And there's a lot of guidance on sustainable drainage systems, be they urban or not. And certainly I moved into a new development last year, and sustainable urban drainage system is part of the development. Just take a step back for those non-technical. Decentralized wastewater treatment plant, you mean septic tanks or?
No, I mean a smaller unit of treatment than the gigantic centralized wastewater treatment plant. So something that is closer to...
small trickling filter site or something along those lines, where the wastewater treatment plant would be one of the big urban behemoth sites that produces energy and the likes.
And I mean, there are different reasons why you would want to build these decentralized things. I'm not a specialist in the field, but I can very much imagine that you might not want to have to, energy-wise, pump this water all the way to one big central water treatment plant.
And you're right. In the UK, we have around 10,000 wastewater treatment works, of which only 3,500 of those 10,000 treat more than 50,000 litres a day. Where in other areas of the world, you'll have a municipal treatment works where it will be pumped to the centralised. So it depends upon the style. Yeah.
So let me show you what's happening. What you see there is the reservoir stress. So if I click on it, you actually have a detail of what's happening. It's over 20 years. It's a projection over 20 years on daily kind of stimulated data. So what we look is we see that we've got a stress of 55%. That means that for every one of the 20 years, there are years in which if there is more than 10 days during which the reservoir level is less than half, then it's considered a stressed reservoir year.
So that's based on climate change, weather patterns.
It's based on just measuring the level of your reservoir. And if you increase your rainfall, for example, so here I can change things like your rainfall. If I increase my rainfall, then you will notice that, obviously, your
stress goes down.
Is not as stressed as it was. So if I put it back to normal, we start, if you want, this game scenario in some sort of middle situation where, the water demand is met 100%. If I click on water demand, what happened is it would be considered not met if you've got an empty reservoir for more, seriously, for more than 10 days. That means you cannot meet the water demand, which would be pretty catastrophic, right? So we can refine this concept and the way we evaluate them. So with stress, we can meet all the water demand, but the reservoir is kind of stressed. Your environmental flow, what you let go to the river, is around 75%.
So that's environmental flow. Give me a definition of what that is.
So by here, it's the percentage of the original river flow that you let go in the river. So the reservoir,
so what isn't taken up by the reservoir, yeah.
Yeah, absolutely. What's not taken by the water demand, basically, what you can let flow in the environment in your river.
Mm-hmm.
So what you can do,
what you don't abstract, basically. Yeah.
Absolutely. So we've got, for example, if I click on the reservoir here, you could change what you let the discharge, what you let go to the river by default. And when your reservoir is considered as stressed, like less than half full, then you can change that you only redirect 20% of the water to the river, because you want to put some emphasis on your water demand and things like that. So there's all sorts of things you can change, you can play around with. There's different ways to influence what's happening in your river. And here we got also a measure of pollution downstream and midstream. So after midstream would be after your decentralized wastewater treatment plant, and downstream would be where the CSO, where your untreated water is left, and also where your central wastewater treatment plant comes, where the treated water comes out.
So what would be cool on here actually would be if you had environmental stress.
Yeah, environmental stress is here.
Yeah,
it's actually the COD we're measuring here.
Okay.
So what we are seeing at the very bottom, if I click on it, you have, if you want, a measure of the amount of, I think, the chemical oxygen demand.
Mm-hmm.
So the amount of oxygen that is potentially deprived out of the water because of all this nutrient you release in the water. It will, make the local algae take away some oxygen out of the flow. So that's a measure for each liter of water, the number of milligrams of oxygen you deprive the water from.
So the techie in me, why COD? Because normally we'd be measuring in BOD coming out of the treatment works, or
it could be
some
BOD.
places TOC. Yeah,
it could be BOD. We just made a decision. We had to start somewhere with some sort of indicator. We use COD because also it was easily relatable with the way we compute things. There is a model, a system dynamic model that runs in the background that looks at, for example, when you look at a house, if you change your toilet, the amount of the concentration of the water that comes out, the used water that comes out of the house would change, but also therefore the COD will change. And I think we use some literature to evaluate what comes out of the house based on COD. So we kept things in the same kind of format.
I mean, realistically, I'm not going to get into it too far here, but BOD is almost it's something we've used for best part of 100 years now, if not a bit longer, 110 maybe. It's kind of reached its day because it's not easy to measure, and we're getting down to, coming out of treatment works, I think we're getting down to ridiculous levels. And actually, you can't readily really look at BOD, as you say, coming out of a toilet, coming out of a sink, coming out of a conventional shower. So yeah, it's COD is a great way of doing it, and we can to a certain extent relate it. Certainly in the Urban Wastewater Treatment Directive, to give everyone a bit of scale, Urban Wastewater Treatment Directive has a limit of 125 milligrams per litre of COD. So that downstream water quality going out to the sea, maybe in this, or out to a larger river in this, that I would consider to be unacceptable.
Yes. So we are in this typical situation, and it's kind of looking a little bit like what we're watching sometimes in the news. Now there are different things. This is not acceptable, but this is like a normal kind of regime. What happens if you double your population? Because it happens quite often that for small towns would become, the climate is nice, becomes quite touristic, attracts lots of people. Then what would happen to your toy town? So I'm multiplying the population by 2, and looks what's happening to the system. Look, suddenly you're stressed 100%, your water demand is not met, your environmental flow is not great, and your pollution level is even worse.
Yeah.
And it's kind of easy to see that it's a system that's on edge. It doesn't take that much. Double your population, and you are in a dangerous area, suddenly, environmentally speaking, but also for satisfying your water demand.
Yeah, I mean, it's interesting because I know, speaking to a lot of colleagues in the water industry, especially on the smaller wastewater treatment works, what they found during COVID, with everybody staying at home, was the stress on the wastewater treatment works, say an urban wastewater treatment works, because everyone wasn't going into the major cities, they were staying at home. There was a population shift more towards the rural population. So if you decrease a large wastewater treatment works by 1%, well, it doesn't matter. Some of these works, I'm talking the big ones at 2 million pop, that's 200,000 people. You've just increased that work, your system, by 300,000. That's not a big increase to share out to all these rural works that exist. So we've seen this in the coronavirus pandemic, with people moving out to rural areas. We've seen this population shift, and it would explain quite a lot of what's going on.
Yeah. On top of it, there is this thing about what can you do? We can experiment with different components, different measures. So I'm going to take one example. I'm going to show you what happens, what's the influence on the whole system if you decide for all the houses in your town to have fog shower head, like one of these fancy shower heads that just pop out this fog of water, so it consumes a lot less water.
Yeah,
you just change the head.
Yeah, these are the aerated shower heads that you can get and make it feel nice and luxurious.
Yeah,
use a lot less water. Yeah, okay.
So what happens to the whole system if you do that? So I'm going to click on fog shower. So look, your stress reservoir is 55%. You meet 100% of the demand. Your E-flow is 75.6%, and your COD, let's pay attention to the COD, 365. Okay, so we got that. Now I click on fog shower. What happens is, instead of being stressed 55% of the time, your reservoir is stressed only 25%. So I'm going to go back. It's going to animate. Okay, I'm going to go back to a normal shower. So if you look at the graph on the top, normal shower, the amount of years where your reservoir is, critically stressed is in orange. And if I click into fog shower, look at the difference on the
massive impact
stress of your reservoir just by changing the fog shower. And it goes further than that. Let's look at your COD. Okay, so your COD is 365. So you would think having some fancy stuff that uses fog shower might be a great thing for the environment. But actually, if I click the fog shower, it increases the concentration. It goes up because
less flow.
The stuff that comes out of the house is more concentrated, isn't it? So you get that too. So there are several mechanisms coming at play, because if you combine these things with, let's say, for example, rainwater reuse. If I click on rainwater reuse, then what will happen is suddenly the stress goes even further down. Your environmental flow from 75% goes to 82%. So you got a lot more water in your river because your water demand has gone down. And your amount of pollution, your COD, has gone down.
Dilutes it right down.
Yeah.
Because there's more environmental flow.
Absolutely.
Yeah.
Absolutely. So you get that. Now you would wonder, okay, we got some fancy fog shower. Our stress is minimal. what happens if, let's say I've got a normal house, no fancy shower, but what happens if I decide, because I'm environmentally conscious, I decide to add this fancy, super great toilet, like vacuum toilet, for example.
Mm-hmm.
So what happens, you look on the right side, the stressed reservoir, and I'm going to add the vacuum toilet on top of the rainwater harvesting. So what happens is there is zero change. It's exactly the same. So you've invested quite a lot of money to put vacuum toilets. You've also put some rainwater harvesting, but actually it was totally useless, because your rainwater harvesting allows you to reuse things for your gardening and for your toilet. But you can only reuse up to, I don't know, reuse rate might be up to 25% or something like that. But adding on top a vacuum toilet is not really going to help, because you're already reusing quite a lot of water. So there are, on its own, the vacuum toilet is great, but if you combine it with rainwater harvesting, it would be a waste of money. So already we are getting aware that some choices are absolutely great, but some other choices, are not optimal there.
So it's very much looking at the combination of choices that can be done at the household level.
Yes. Now, what's interesting is I haven't shown you the energy side of things. So this is your water treatment plant energy use. It represented around 2% of the overall energy footprint compared to the household. So what happens is, if you have an energy saving device on the water treatment plant, you're going to save something over 2%. But if you've got water energy devices in the household, you're going to save over 98% of your energy use.
Wow.
So even it doesn't seem like much, if you got a tiny little rickety device that saves a little bit of energy at the household level on your whole town, you're going to have a massive impact.
Yeah, because your population was 300,000.
Yeah.
So 300,000 rickety devices. Slightly tongue in cheek, but yeah.
Yeah, it's actually 2-point-something person or 3% per house. So we look at the device per house. So it's around 100,000 devices, and you could put it that way.
That's massive.
Yeah. So what happens then if you? Well, we can look at that on your thing. There is actually, we got some energy saving dishwasher. So if I look, for example, at house A. The house you got, so it calculates something about the cost. So you'd have to ignore the cost, because we entered something that was 10 times more than the actual price. So we are still refining, still a prototype. So when I saw the bill of 6 billion, I was like, what? Well, I just added a shower head or something. And I was like, so we're combining things. But what's happening here is you got your energy use. You could see quantified the water treatment plant, 10 gigawatt hour of average per year, and the household 571 gigawatt hour. And if I actually change for, the rainwater reuse might change things quite a lot. So we in rainwater reuse, I reset the picture. We got without rainwater reuse, normal house, nothing fancy, 571 gigawatt hour of consumption for the household.
If I start using, treatment's gone up a couple of gigawatts. So
yeah, if I use rainwater reuse for some reason, I'm going to use that, and I'm going to re-click on the picture. What happens is your household hasn't changed, but your consumption, I think, has changed. So it
has. It's changed by a couple of gigawatt hours. That tells me is okay. There's the treatment works just isn't treating that little bit of rainwater in a year. It amounts up to quite a lot.
So let's look at it. Actually, I'm connected. I look at the wastewater treatment plant. So I'm going to click on rainwater reuse. What happens then? It goes
2 gigawatt hours a year.
3 gigawatt hours of difference.
Wow.
That's not much. There is a much more dramatic impact if you start changing things like the fog shower.
Mhm.
The fog shower, okay, so 571 gigawatt hour in the household use. If I put the fog shower, suddenly it's 387 gigawatt hour in the household.
Just stick on the rainwater reuse there as well. See if it goes down even further.
Yeah. So if you want to show the rainwater reuse, so this one is still a prototype. So your rainwater reuse rate is for households 0% because there's no special device.
Yeah.
If you start putting your fog shower, it becomes, let me re-click on it. It becomes...
Rainwater reuse isn't on.
Oh, okay. All right.
That'd be right. Yeah.
35.3%, because the fog shower plus there is normally a ceiling. Normally you can only reuse for your garden and your toilet. So normally it's 25.9% as a ceiling of water reuse, but because you use the fog shower on top, it reduces your water demand. So it's kind of an extra bonus.
I mean, to be honest, not being funny, but rainwater reuse there and the fog shower, that's reduced the energy at the treatment works by a third.
Yeah. And also it's reduced the energy used in household from 571 gigawatts to
down 387. So there's a carbon impact straight away. That's quite massive. quite a serious carbon impact. What impact has that had on the environmental?
So from an environmental perspective, from 300,
you're in a good place.
380, you got to 96 milligram per liter, which becomes environmentally acceptable.
Mm-hmm.
And on top of it, if you want to go crazy, if you just connect, I think, to a sustainable drainage system, then I think you have a killer combinations for your amount of CSO events. So we are still perfecting the model of CSO event. We had something fairly rough, but now we're adding even a hydrograph over 3 hours if it's a rain summer kind of profile, or 6 hours if it's winter. So we have adjusted it so it's actually more sensitive. So we got more CSO events coming out of the system. It's actually even more sensitive to it because more realistic. So it's still in the making. But if I connect to the sustainable urban drainage system, so what's happening is you even lower what's going on with
you lower that down. It's interesting. Again, you've gone from 12 gigawatt hours down to 7 now. That's not to be sniffed at.
Yeah.
It shows the importance of what can we do at a household level and I'm thinking more the net zero target here. Pollution in the river, brilliant, fantastic. We've reduced that from 380 milligrams per litre of cod down to 60 or 70. But what can we do in the household? Sustainable drainage system, great. We should be building more of it. Of course we should. Rainwater reuse, okay, it's not going to apply everywhere. It's not going to apply in an urban area where a lot of people are in flats. But that's, as you said, a killer combination there.
Absolutely. And you have to consider, are you actually considering building a separated kind of sewer system?
Yeah.
You see, the whole infrastructure nightmare that would, and the cost, which would be massive, that you have to compare that to just, making sure you've got rainwater reuse and a little bit of sustainable urban drainage systems.
Well, it's interesting, Tom, to come on to that sort of pollution issue. I mean, I know people have done a rough impact, and how do we separate the sewers out? How do we solve this problem we've got at the minute? And I know a figure of £100 billion has been bandied around. But and yes, there's a lot to be done about education. There's a lot to be done. Yes, yes, the water companies can do more, and of course, everything going on. And I think everyone at the water companies would say, yeah, we can do more. But actually, there's a lot that can be done at our household level as well. And
Absolutely.
maybe, I don't know, maybe this is planning issues. This is getting, I don't know, it's government policy really, but maybe it's a case of, yes, there's government policy around SUDS. Where I'm living at the minute, there wouldn't be any SUDS if there wasn't government policy in place. In reality, there is. It makes a beautiful natural landscape. I'm actually quite thankful I've got it, because there's lots of wildlife around here, and I'm not in a rural location. So it makes sense for both health, safety, and wealth. It makes sense in terms of people welfare, but also it makes environmental sense as well.
Well, yeah. By the way, we started to play with these ideas about combined versus non-combined sewers, and we actually put what happens if you can convert a percentage to non-combined sewers. So if you do only 80%. So if we start, I'm gonna reset the settings to the normal starting crisis kind of where we were. So far with our fancy, not very fancy, but rainwater harvesting, we got around 90 milligram per liter.
Yeah.
What happens if for the wastewater treatment plant with an undisclosed cost, I manage somehow to put only, let's say, 70% as combined sewer, and I managed to build enough infrastructure to have separated sewer for 30% what's treated.
Mm-hmm.
So if I click on that, then look at the impact, 330 instead of 380 of COD.
Mm-hmm.
So it's actually, weirdly enough, for the huge price tag that would go with it, a lesser impact.
Yeah. So I know at the minute there's the piece of work that's going to be being done around, okay, what's the situation with the pollution crisis? Is it basically decombining, separating all the sewers out nationally at vast sums of money? I think this kind of says no. I think,
but I think as a policy,
this is a generalization, of course.
Yeah, it's a little virtual model, so it doesn't have the exact specific characteristic of one hydrographic thing or another, but it gives you, it's very, very square as a model. We got a system dynamic model with like proven, models behind it, and it's actually pretty accurate in this closed system. So it gives you a good balance. And I think for a policymaker, I don't think that decision makers know what a sustainable drainage system is. I mean, most of them, I don't think they really do know. But if they become aware of what happens in this little system and what the elements' role are, and if they are given by somebody the question, should we bind, should we stop having combined sewers? And they've played that little stuff, and they actually see, they could say, what about we build a couple of sustainable drainage system, in our town? Then that would, that's the kind of thinking, the kind of communication, the kind of learning that we can provide, because there is no school for being a policy maker. I mean, because there are so many different technical subjects you can't necessarily know about. And this is the kind of stuff you spend 30 minutes looking at that, and at least you got a pretty good appreciation of the kind of stuff you could potentially do to limit the damage at lower cost.
Absolutely. And I suppose it shows where we can invest all our efforts. I mean, when you look at Germany, example, massive water reuse, even at a household level. You look at Israel, massive water reuse, that's out of need. The argument is, of course, we don't necessarily need that in the UK. And that's why water reuse in the UK is relatively low. Yes, we have a pollution, and this serious game actually just playing with it for the sort of 20 minutes that we have it's quite startling what you can do with a serious game. And of course, this looks at it from a holistic point of view, which is a real benefit.
We have just explored a few portions because you can tell stories. We can explore different scenarios. We are adding little bits and pieces. For example, for different case study, we are thinking a Mediterranean version of that, where we'd have a desalination plant and an aquifer management problem.
Yeah.
So if you let your aquifer goes too low, then there's a salt infiltration, all sorts of little problems which are very specific to a certain location. But okay, that could be a long story, but let's just say we are opening the gate to something that's interesting for not just the general public, not just also the policymakers, but even sometimes the actual service providers, because they might not be aware of the links between some of these technologies and the layers that are inside there.
And definitely, and I think that shows the real power of it. And to be honest, I think we saw this with COVID as well. And I know you did. There was a group of people, award-winning group of people on sewers for COVID, that did a great piece of work. And it was the Royal Society?
Sewers for COVID. It was a great. We actually had Dragon and other people on board, and I asked them.
That's Professor Dragon Savage of KWR on the University of Exeter.
So pretty senior figure, and he accepted to work with us for 48 hours on a hackathon. No matter who you were, head of what institute, we all got together, we all worked on it. If you don't know how to program, then you provide a piece of text, or you provide some feedback, or you read something. So we all got our hands together, all hands on board for 48 hours. It was great. And we came up with this idea of a virtual observatory based on putting sensors in the sewage to detect the concentration of the virus. And at different postcode points, potentially, then you can infer from the postcode location and the data you've got from the public what you could do. For example, if there's a retirement home at this postcode address and you measure a spike that shows you before the first people even come to hospital, the concentration of virus, because when people excrete the virus in the sewers, you have got an immediate measurement of that they're going to be sick in the next few days, right? Before they even come to hospital. So you have 2 weeks in front of you to actually prepare the ground, start sending perhaps a list of consumable to the retirement home, like for gloves and things, or to the hospital, or if there are NHS worker on the ground, send them an alert for their kids to, for example, or for their supermarket groceries, or knowing, preparing the ground already in advance. We've learned things during the pandemic. We've learned that taxi drivers, security guards were actually the most touched people by the pandemic. So perhaps we could actually, knowing there's a taxi driver or a security guard that lives at this address, you could already send them some protection equipment or something. All sorts of things you can do from a virtual observatory. The idea is you can anticipate. So it's becoming like you have the power to have a checklist, like for a pilot or a surgeon. When there is a trouble, you give them a checklist of action to take so as to minimize the impact.
Minimize the impact, minimize the risks.
Yeah.
Yeah, it's interesting. It's fascinating what can be done. I've been a long admirer of serious games. When I saw the work that you've done, and I think we met at the University of Exeter. There was the event down there, to me, the first thing was serious games. I can't see it happening, and the more and more I've spoken to you over the years, the more I can see this is, to be honest, a brilliant tool for not only public education but policy making, But also, I know you did some more work on strategic. Was it the strategic development goals and the importance of water, and did the whole levers between water and electricity and
so there was another quite a big game, that one. And we tried to make the most complex thing you could possibly imagine, which was the nexus, model the nexus. So the interaction between water, energy, land, food, and climate in
big hairy goals.
Yeah, gigantic hairball kind of network with all sorts of feedback loops and connections. And typically we implemented, for example, for the wall of Greece, we had 14 regions, and we tried to gather data, specifically model everything we could think of and put it in connection. And if you, for example, you could measure weird stuff like when you apply policies, you could see the consequences, and you could start seeing the difference. For example, there's one region in Greece in which they do a lot of cotton. And you can start thinking, for the whole of Greece, if I put water saving, measure for the industry to reuse the water, but also for homes, for all the homes and all the industry, would I save more water rather than if I just change the cotton culture in this one big region of Greece and replace it with something that consumes less water? And we found out that actually you save more water if you stop the cotton in one region.
Yeah, but as long as it wasn't the olives. Don't affect the Greek olives and the Greek olive oil.
Actually, if you replace it with olives, it's perfect. But it also,
there we go.
It also had an impact on things like electricity consumption because, you consume water by pumping it. You consume electricity when you pump water from the wells and all that stuff. So we had this whole nexus link, and we tried to make this very complicated. We try to reduce the complexity of that big problem where everything is interconnected. We learn things out of it. And it's essentially for policymakers. So this was something else. But now we moved on. We learned a few things from you always make mistakes, or you always learn from what you do. We learned a few things on the way. And now the next version is what I just showed you, which is next gen, which is something less complicated. I think we tried something which was perhaps a bit too much. And sometimes it's better to be more focused. So this little toy town is perfect because complexity-wise, you can wrap your head around that, and you can learn enough. You don't need for things to be super precise and super complex. You just need something that's good enough to give you an order of magnitude to appreciate the effects.
And it does. I think people can really see this at a local level. Certainly, it's taking the system approach, and I think the system approach is where we should be. We don't think enough of our systems. Something we always say at wastewater education is very much around water is not waste. Water's not waste, and it is. We do pump. We consume water through the houses, out through the wastewater treatment works. And guess what? Downstream, that's going to get picked up by water treatment works again. But it is that circular nature. And I remember when working for a water company, they're saying, well, actually, what we do at a wastewater treatment works can affect a water treatment works as well. So really, it's thinking of all the environmental systems and how they work. And I think Toy Town makes us think again. Where do we have the policies? Where do we invest our time? We've got a report coming up next year, as it has been promised, of, well, do we look into the massive option of replacing all our sewage system with a separate system? Wow, that's a big decision. That's £100 billion. I think I was working out the other day. It's about £600 per person per year. That's more than most people. That's more than most people pay in their
That
water bill.
is huge. That is huge.
Absolutely, it's huge. All right, I'm taking a finger and air estimate as the 100 billion was a finger and air estimate. So yeah, but it's in that order of magnitude. If you did that, which is more than twice the water bill, and if you think that that's about right, because guess what? I think this asset management period, what's it cost to run the water industry in England and Wales? About 51 billion. So it's 10 years worth of bills. If a water bill's roughly on average £300 a year, double it. So you could have run the water industry in the meantime. So instead of your bill being 300 quid a year, it suddenly becomes 900 quid. Yeah, and of course, no customer's going to want to pay 900 quid. So what do we do? What's the solution? Well, actually, guess what? It's rainfall, and it's rainfall recycling. It's water recycling. Is it fog showers? Perhaps not. And we've got to look at the tools that are available to help us make these decisions. And maybe somebody should be coming to you now and saying, Mehdi, we really want you to develop a serious game to help us make these policy decisions.
And I'll tell them, give me 3 months and it's done.
It sounds like a no-brainer, to be honest, at the end of the day. So how do we help? And how do we make those big environmental decisions? How do we make the housing decisions?
Well, I can tell you very little about how we make these decisions, because after all, I'm only a computer guy. I mean, the programmer, the scientist somewhere in the background. But I can tell you that thanks to recent technological advancements, such as all these cloud servers and all that, making a serious game doesn't require much money. It's becoming a fairly small thing, and it doesn't require much time. But it requires some expertise, because you need to know what you're doing.
A lot of expertise, Mehdi. I mean, yes, it's not only computer programming, but it's the technical expert behind it, helping develop. Yes, there's lots of academic papers out there, but yeah, I mean, to do it, this looks a very simple game, but guess what? The data engine, the engine that runs that game is not simple behind there.
There is a very talented guy that helps me with the system dynamic modeling, Barry Evans, and now really I need to mention him, because thanks to his work, we're working as a good team. And I must say, the game doesn't exist on its own without having a good, accurate, but fast model that simplified enough to run under less than a second, but good enough to give you a good appreciation of what's going on. And I think that's the key thing. So you see, I'm probably not going to be able to continue on and on for much longer, but for example, the concept of a digital twin, which is something that's going on at the moment, quite fashionable, plugs particularly well to serious game if you're a company that's invested a lot of money to get accurate measurement, absurdly accurate measurement of a virtual replicate of the whole town. What do you do with it? I mean, what's the next step? Okay, you could see a system. Well, you can then plug this accurate data to a smaller kind of serious game to start asking questions. What if? What can we do?
Yeah, I mean, certainly I've seen it. I mean, you virtually came out to Valencia before lockdown, and I actually went out there, and they've got a great digital twin over there of the water distribution system. And yes, they use that as both a training tool, but also, what if scenarios.
So this technology is great, and I think it's can potentially be, quite complementary, because the problem of the digitalization of water, well, it's nice to have accurate measurement, but can we use it then to connect it with other layers that people don't even think about? For example, when you have a shopping basket for your groceries online, it might have actually a water footprint to everything you buy. If you buy locally produced stuff, it could actually connect to that stuff. I mean, to what if you buy a kilo of chicken every week? Well, actually, it might help your system rather than if you used to buy a kilo of beef.
Yeah,
and it might actually have an impact. So all this is coming together thanks to this digitalization, technology.
So it's helping people realize their environmental impact, really, in a way, and allowing people to make that informed decision.
Absolutely.
Which is, I think, probably what you want to call it, digital transformation, smart water, whatever, is all about. And it seems to me that that serious games, which I wouldn't have thought 3 years ago was part of it, is absolutely front and center, and it's one of the tools that we've got to use.
Well, one thing is for sure, I'm looking forward to work with people in the industry, because I don't think academia should exist on its own. I think we should really work together, not just with members of the public, but to the actually captains of the industry too, to make sure that we got something that's put to good use.
Definitely. Well, there's a challenge up. We've just seen the Off-Watt Innovation Competition results released in the past few days of the IWC competition. I would love to see something like this in a future competition as something that we can use within the water industry to develop moving forward and help us with the decision making. So I think it's a case of watch this space.
So yes, I'm looking forward to that. I might, give it a good try, and also perhaps even in future conferences in the industry, having little serious game-based event to try to answer technical question, like even mini esport.
I think that is more than capable. I run the apprentice competition at WEM. I'm thinking about technicians as well within the industry, and I think this sort of thing could be definitely used for educational purposes as well.
Well, count me in, because from May onward, I'll have the first live cloud servers serious game version of what I just showed you. And then afterward, after the summer goes, we'll be able to organize serious game events online for conferences, and it will be able to accommodate as many people as we need, because it will be elastic technically. It will accommodate, no matter how many participants wants to come.
Well, in that case, I think we're going to make a date on that, because we've got WEM coming up in October, and this year it's virtual. So I think that's, if you're ready for October, we can maybe have a maiden launch.
It's on.
Done. Thank you very much, Mehdi. It's been an absolutely fascinating discussion. I've certainly enjoyed it, and I hope you've enjoyed demonstrating Toy Town and Millbrook. And hopefully we'll watch this space.
Well, I've enjoyed it equally, and looking forward to hear more even from you and from other people which are interested. I'm always happy to help and present more, and even more than presenting, if there is some interesting problems to model, give it a try.
Just give you a call.
Yeah.
So thank you, Mehdi.
Thank you, Oliver.
Take care.
Bye.
Bye.